Flying taxis, they've felt like science fiction for so long, right? But these eVTOLs, or electric aircraft, have exploded into this multi-billion-dollar industry that is, believe it or not, right on the edge of becoming a reality. They promise to completely change how we get around our cities. But behind all the hype and the cool designs, there's this huge debate going on, a fundamental disagreement that's going to shape the future of this whole industry.
So let's get right into it. The real question isn't if these flying taxis are coming, it's how they're going to be powered. And believe me, this one choice is splitting the industry into two very different camps, with two very different ideas about the future of air travel. It's really a classic tug of war between a super idealistic vision and a more down-to-earth, pragmatic approach.
At the absolute heart of this whole thing is a choice about power. Every single company building one of these aircraft has to place a massive bet. Are they going to go for all-electric purity, chasing that green zero emissions dream? Or are they going to take a more practical hybrid path? And this isn't just some minor technical detail. Oh no, this choice impacts everything: the range, the speed, and even the kinds of jobs these aircraft can actually do.
Okay, so let's break down these two competing philosophies. On one side, you've got the battery electric folks. The easiest way to think about them is like a Tesla for the sky. They're 100% powered by batteries, which means zero emissions in the air, and they're also mechanically way simpler. Then, on the other side, you have the hybrid electric approach. This is where a generator, think of a really small, efficient jet turbine, is actually creating electricity while the aircraft is flying. That electricity then powers the motors, and a small battery is kept on board for an extra power boost when it's needed, like for takeoff. So let's start with the dream, the one that gets all the headlines, the all-electric approach. I mean, this is the vision, isn't it? The idea of creating a totally new kind of transportation that's genuinely clean, incredibly quiet, and just perfectly designed for hopping across the city. And the promise here is, well, it's incredibly compelling. Zero in-flight emissions isn't just a marketing line. It's about the quality of the air we breathe in our cities. And being quiet, that's a total game changer. It's what could get these things permission to land in our neighborhoods, something helicopters have always struggled with. Plus, the simple fact that electric motors have fewer moving parts means less maintenance. And that should, in theory, make flights cheaper for all of us. This is that clean, green future we've all been hearing about. But, and you knew there was a but, right? That beautiful, clean dream runs headfirst into a very real, very heavy wall. There's one single thing holding back this all-electric revolution, and we can call it the battery barrier. And let me tell you, it is a big one. And look, this isn't some far-off theoretical problem. This is happening in the real world right now. Take Joby Aviation, one of the biggest names in this space. They pretty recently had to revise the expected range for their S4 aircraft. They thought it would be 150 nautical miles, but they had to knock it down to just 100. That's a 33% drop. And it's a direct result of the limitations of the batteries we have today. So why is this happening? Well, it all boils down to physics, really. It's called the energy density problem. A pound of jet fuel packs a massive amount of energy. A pound of batteries, yeah, not so much. It stores way, way less. So if you want more range, you have to add more batteries. But more batteries add a ton of weight, and that means you can carry fewer people, less cargo, and the whole aircraft just becomes less efficient. It's a really frustrating cycle. And that very frustrating trade-off, well, it leads us directly to the second path, the hybrid reality. The thinking here is actually pretty simple. Instead of waiting around for some miracle battery breakthrough that might be years away, why not use the proven technology we have today to build aircraft that can do more right now? A hybrid system is actually a pretty clever solution. You've got this small, super efficient generator that's just humming along, constantly making electricity. That electricity is what powers the same quiet, reliable electric motors that an all-electric version would use. But here's the kicker. At the end of the flight, you can just refuel it with liquid fuel in a few minutes, instead of waiting an hour or more to charge up a giant battery. And hey, don't just take my word for it. NASA, yep, that NASA, did a massive market study on this. And they put it very bluntly. They found that for really demanding, high-stakes jobs like being an air ambulance, the batteries we have today are a major roadblock. Their conclusion? Hybrids could be the key to making these critical missions happen sooner rather than later. So this leads to a really critical question. When you're talking about a mission where life and death are on the line, an air ambulance,
how does this choice of power source actually perform when the clock is ticking and every second counts?
Okay, get ready for this because this is where that battery barrier becomes painfully clear. According to NASA's research, a regular helicopter can do a typical air ambulance mission from getting the call to being ready for the next one in about 130 minutes. The all-electric eVTOL, even though it's faster in the air, takes an incredible 275 minutes to do the same thing. Why the huge difference? Because a massive chunk of that time, 145 minutes, is spent just sitting on the ground waiting for its batteries to recharge.
And now, look what happens when you bring in the hybrid. By getting rid of that long recharge time and just doing a quick refuel, the hybrid eVTOL gets the entire mission done in just 90 minutes. That's not just way better than the all-electric, that is 40 minutes faster than the helicopters we use today. And for missions like this, saving that much time is everything. So what does this all mean? It means the debate isn't really about finding one single winner. It's about realizing that the mission itself is what defines the machine. There is no single best power source. There's only the right tool for the right job. This table really just lays out the whole dilemma perfectly. All-electric is amazing for its zero local emissions and its simplicity. That makes it a great fit for short, repeatable trips across a city, like an air taxi where it can charge up overnight. But if you need longer range, if you need to turn around fast, and for those really tough missions like an air ambulance or flying between cities, the hybrid's performance is, at least for now, just in a different league. Of course, this whole debate is based on the technology we have today. And as we all know, technology is moving at an unbelievable speed. So what's coming down the pipeline that could just completely change this entire conversation? Well, there are 3 huge game changers we need to be watching. First, advanced battery chemistries. We're talking about new science that could seriously boost energy density, helping electric aircraft close that range gap. Second, hydrogen fuel cells. These create electricity from hydrogen, and the only thing that comes out is water. So you get electric power, but with refueling times that are more like filling up a car. And third, a solution that's more about logistics, rapid battery swapping. Let's just look at the impact of that last one for a second. Remember that air ambulance mission? If you can just swap out a dead battery for a fresh one in, say, 10 minutes, instead of charging it for over 2 hours, well, the whole picture changes. That mission time for the all-electric eVTOL plummets from 275 minutes down to just 100 minutes. And just like that, it's right back in the game, competitive with hybrids and even helicopters. So, as we look to the future, that's the ultimate question, isn't it? Will some huge breakthrough in batteries or hydrogen eventually make one power source the obvious winner? Or is the future of flying not about finding a single silver bullet, but about building a diverse fleet of aircraft, with each one powered perfectly for the specific job it needs to do? The race is on, and the answer is going to define what the skies above our cities look like for decades to come.